So we got our ship. It's going to get launched. And the thing we've got to figure out is we've got to figure out what's the initial velocity. So if the angle is 45, like that, then we've got a Vx here.
Yep. And we have to have a Vy.
A Vy. And then there's a V init.
Which is going to go here.
Along the hypotenuse. And that's going to be equal to 65. So now we put on our math hats.
Yay.
It's a good thing we already had the math hats on. But we got to dig out our trigonometry. So what's the one thing you got to remember about triangles with trigonometry?
SOHCAHTOA.
SOHCAHTOA. What was the interesting acronym that you...
So my teacher back in the day, she told me in order to remember SOHCAHTOA.
I'm not even going to be on camera for this. Plausible deniability. Go ahead and tell them.
Is some old hippie caught another hippie tripping on acid.
There you go.
There you go, kids.
That's to see if anyone's watching this, right?
Yeah, that's our beautiful token to remember SOHCAHTOA. And also...
Well, what does that mean, though? What is the so and the...
Yeah.
What is that?
So means sine is equivalent to opposite over hypotenuse. And then cosine is equivalent to adjacent over hypotenuse, and then tangent, or tan for short, is equal to opposite over adjacent.
That's exactly right. So all of these are relevant to today's situation, but
yes.
The ones that we're going to be using are these two, the sine and the cosine. And again, what we're trying to figure out is what is Vx and what is Vy. And so let's go ahead and try that. So let's start with Vx.
So, jazz hands, we're back with fun drawing. And again, so we have cosine, which is adjacent over hypotenuse. And so in this case, adjacent to our angle is the Vx. And our hypotenuse to our angle is going to be V initial, which is our initial speed of 65. And the initial part is actually going to be a subscript because it's really V aught, but we're keeping it simple for the code. And then we know this here equals cosine of theta, as we said earlier, which is going to be our 45 degrees. And so you see, we have to solve for Vx. That's really what we're looking for in this equation. So in order to do this, we're going to multiply both sides by V initial, if that's easier for you guys to understand, and then multiply this side by V-I-N-I-T. And so when we do this, you can see over here that both the V initials cancel, and we're left with V-I-N-I-T cosine of theta equals Vx. And so we have our Vx.
There you go. And so all we got to do is stick that into the code for Vx.
Yep.
We still have more work to do, right? Because we got to figure out what Vy is.
Yeah, but lucky for us, it's pretty similar. It just doesn't use cosine.
Right.
So
there you go. Go for it.
For our sine, just erase everything here. Does water make it come off faster?
I don't know. We can fast forward through this part.
So we know sine is sine again, obviously, which is opposite over hypotenuse, and again, in relation to our theta of 45 degrees. So here it would be sine of theta equals opposite, which is going to be the Vy over the hypotenuse, which is the V-I-N-I-T, which is again our initial speed of 65. So again here we're only worried about the Vy, which means we're going to multiply both sides by V initial. And once we do that, again, they cancel out, and so we're left with V-I-N-I-T times sine of theta equals our Vy. And then that goes into our equation just like how the Vx did.
Yep. Okay. All we got to do is put that into the code, and we should get angry birds like bellicose birds like behavior.
Following said trajectory.
It'll be a lot more fun than it was before. Instead of just like falling down to the floor.
Yeah, it'll actually be doing something.
Yeah. Okay, so let's erase this and go back to our code editor.
Cool.
And I'm going to help erase it to prove to the world. Industrious.